Hi, my name is Ryan, and in today's video we're going to be sketching some graphs. So this is kind of fun to me. I don't know why, I kind of like graphing these kind of ones. So basically let's start off with just the first one. So f to the x, which means basically it's a function plus x plus 3, and then let's go x minus 3. So since we are graphing, we know that there's going to be a graph. So let's do that in green. And then we also know that there's going to be some type of translation. So let's start off by going ahead and factoring this out just so that we can figure out what kind of equation this is. So what we need to know is basically we need to know the first number. So if we take the x times the x, that's going to get us x squared. And really, that's all we need to know right now, because what we're going to find out are the end behaviors. And these end behaviors are going to basically tell us what happened at either if it's going to be up here or over here or down here or over here. So the graph could look something like that, or something like that, or maybe like that. So that's what we're going to be trying to figure out. So let's go ahead and graph that again. So what we know is that it's an x to the 2, which will tell us that if you plug in a number, let's say positive 1, so if x is infinity, all right, so actually let's just write that as x to infinity, then y is going to equal, so since we know it's an x squared, if we put in a positive number, which is positive infinity, any number over in this side, as it goes this way, then y is either going to go up or down. So we know if you put in a positive number, positive 1, it's going to come out to be a positive since it's squared. So therefore we know it's an infinity. Now let's do the same for the negative side. So if x goes negative infinity this way to the left, then we know y is going to equal, so let's put in a negative 1, and negative 1 squared is positive 1, so we know that's going to be infinity. So just that right there will tell us that it's going to be over here and over here. So as it goes that way, it's going to go up. As it goes this way, it's going to go up. That's what that's telling us. Next, what we want to find are the x-intercepts. So the x-intercepts would be, let's see, so it's going to be x equals a negative 3 and x equals 3, since I set this one and this one equal to 0. So we got 1, 2, 3, and 1, 2, 3. Now, let's see. So next what we want to find is the y-intercept. So the y-intercept can be found by setting both of them, basically the zeros, or the x's equal to 0. So if we fully factor this out, then we get, let's see, so we get negative 9 right there. So we know if we set this equal to 0, we're going to get a negative 9. So negative 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way down there. Let's just continue on this right there. So we have a point here, a point here, and a point here, and we want to graph this. So what we have is we know that basically since they're powers of 1 right there, they go through. If they're powers of 2, they bounce. But since basically even numbers bounce, odd numbers go right through. And when I mean numbers, I mainly mean exponents. So this is a 1 and this is a 1 since nothing was written there. So they're going to go through. And then it goes through the x and back up. and there is your graph. Now, this is mainly just sketching. This isn't very, very accurate, but in times it can be. For example, the end behaviors could be more steeper, or they could be more, gradual, depends, but that's basically your general outcome. So let's try a few more. I don't know about you, but I'm having pretty fun with this graph here. All right, so next what we want to do is we want to just find another problem. So that'll be, let's try x squared, and then x minus 2, and let's try x plus 2. So f of x. All right, so let's go ahead, and so we know that this times this times this. You can, if you need to find out if it's for the end behaviors, you can look at this one, and this one, basically times all of the x's together, and then that'll be x to the 4th, and that's how you're going to determine your end behavior. So end behaviors, so if as x is infinity, as x is negative infinity, y is going to be, and y is going to be. So we have a x right there, so we know that it's going to be positive if you put in a positive number, and positive if you put in a negative number, because since it's 4, it's going to be positive no matter what. Next, we want to start our graph here, so let's do green again. There we go. Just for the kicks, what is your guys' favorite color? Mine happens to be green, so I thought I'd throw that in here so that it doesn't seem to be all math. I am human too, So let's go ahead and finish this one. So we know, just by looking at it, that the y-intercept is going to be at 0. And you're probably saying, Ryan, how the heck did you figure that out? Well, we know that it's x squared times a number times a number. So this is going to be times by that, and then this is also going to be times by that. So if you set one of the x's to 0, it's going to make everything else 0. For example, if you have 0 times 1 times 5, that answer is going to be 0. That's just an example right there. So same thing goes for this right here. So what we want to do is we want to now, since we know it's going to be 0, we want to look for some other points. So y equals 0. So we got to set some other ones to 0. So we have x squared equals to 0. Let's try, so we have x minus 2 equals 0, and x plus 2 equals to 0. So this will get you x equals 0, since x squared, if you root that, it'll get you 0. We also have 2 and negative 2, since this one will get you 2, or negative 2, and this one will get you 2. All right, next what we want to do is we want to start graphing this. So we have all of our points and all of our end behaviors. So let's go ahead and graph this in blue. And we know our end behaviors, again, are going to be positive and positive. We know it's at the 0 for our x and y. And we know it's going to be 2 and 2. So, as I said before, we have a 1 right here and a 1 right here. Odd will go through. Okay? And even will bounce. So when I say bounce, I mean like that. And there's your graph right there. As I said again, it's not fully accurate, but it is a sketch and it will help out. This could essentially be something like all the way down here and then come up steep maybe, and then back. It could be something steeper, it could be something longer. It really depends, but that's pretty much your sketch right there. There's where your x and y intercepts, your end behaviors. that's all right there. Let's just try one more for understanding purposes. So let's give it one more go. So let's see. So we got x squared, x plus 5, and x minus 3 to the 2. So let's see. So we have x to the squared times x to the squared, which is x to the 5th. So your end behaviors will be x, as x is infinity, x is negative infinity, y, and y. And you know that y is going to be, if it's a positive number, it's going to stay positive. If it's a negative number, it's going to stay negative. Because you know, if you put in a -1 times itself 5 times is going to be negative. So there's your end behavior. Let's figure out y. So y is the same as last time. Y is equal to 0, since if this is 0, it's going to automatically, since it times is each one, it's going to automatically turn into a 0. That's a little shortcut if you need to know. If something times something and one of them is an x, automatically your y is going to be 0. So next what we're going to find is, let's see, so we got that, so we're going to again set them equal to 0. And then it's got x minus 3, so squared equals 0. So then what we have here is we have x is equal to 0, since you square rooted them. X is equal to -5. Let's make that a little more clearer. It's equal to -5. And then basically what you could do is you square root it. Since that's equal to 0, then you have x minus 3 equals 0, x equals 3. So then your x-intercepts are 0, 3, and also -5, or -5, 0, 3. Doesn't really matter what order you put them in, because you're going to graph them. So there we go. Now let's get ahead and graph it in green. Okay, so we got our point for our chart, and then we got our points. So 0, 0 again, right there. We got 3, 1, 2, 3, and -5, 1, 2, 3, 4, 5. So then, let's make that a little better. So now, what we want to do is we want to figure out what's going on up here. So we have an even, an odd, and an even. So let's just do our end behaviors. So we got up here is this way, down here is this way, and then our end behaviors. So that's our end behaviors. As it goes positive, it goes up, positive, and as it goes down to the left, negative, it's going to go down to negative. So next we have this. So we have -5 right here, and you could see it's an odd, so it's going to go through. And then we have a x squared, which is a even, which is going to bounce. And then we also have x minus 3, which is also an even, which is going to bounce. So that's what your graph's going to look like. So hope you guys enjoyed this video. This is pretty much it. This is sketching graphs, basically, or graphing sketch, either way. I find this stuff kind of pretty cool, very useful. Actually, I don't know about useful, but it's pretty fun. Definitely helps out in some of your higher classes, you know, like pre-calculus, stuff like that. You'll be using this in. I hope you guys enjoyed this video. This one was a little bit longer, but I liked doing this one. I like graphing like this, so hope this was fun, hope this was useful, and I hope you guys enjoyed. I'll see you in the next one.